Good morning, students. Today we are going to discuss about module number 1, that is basic concepts. Here we are discussing about that problems on network reduction method including star delta transformation. Okay, now we are going to discuss about that the problems on star to delta and delta to star network. Let us go through the problem number 1, that is convert the delta network in figure A to an equivalent star network. So to convert the given problem network, this is the network what they given in the problem. I am writing that solution here for the problem as to convert this delta network into this star network. How it is possible to convert that the given delta network into star network at here? So as we know that the formula to convert the delta into star. So to convert the delta into star in a very simple manner, here I am going to write a star network in delta. So here delta I am taken in dotted line and star I am taken in thick line. Now I am going to draw the thick line inside of the dotted line of delta. So the delta network terminals A, B, C. Here also I am taken A, B, C. Inside I am writing that the star. Here one resistor, here one resistor, and here one resistor. I am going to name the resistors of stars as R1 here, R2 here, R3 here. So now I want to find out the value of R1. How to find out the value of R1 at here? The value of R1, the value of one of the branch of star network, that is R1. R1 value is equal to here RB into RC divided by RA plus RB plus RC. This is the formula. So the value of R1 is equal RB into RC divided by RA plus RB plus RC. Here in the given problem already they given that RB value as 10 ohms and RC value they given 25 ohms. Therefore 10 into 25 divided by RA plus RB plus RC, that is 15 plus 10 plus 25. 15 plus 10 plus 25, that is equal to 250 divided by 50. 50 ones, 55 to 50 ohms. Therefore the value of R1 is equal 5 ohms. Next, again I want to find out that the resistance of R2 here, which is connected here to the terminal B. Then what is the value of R2? The value of R2 here it is the product of this resistance and this resistance. What is the resistance? The product of this resistance means the value of R2 here, the product of the resistance which was offered in delta, that is A to B into B to C. What is A to B value? It is RC. What is B to C value? It is RA. Therefore RA into RC divided by RA plus RB plus RC. So 25 into 15 divided by 50. So if you do the simplify, it becomes 7.5 ohms. Similarly, what is the value of R3? The value of R3 is equal here, that is the product of the resistors which is connected between terminal C to A into B to C, that is RA into RB. Here RA, here RB, that is 15 into 10 divided by RA plus RB plus RC, that is 15 plus 10 plus 25, that is 50. 150 divided by 50, it is equal to 3 ohms. Now we are converted that the values of that given delta network into star equivalent network, then whose star equivalent resistance values R1 is equal to 5 ohms, R2 is equal to 7.5 ohms and R3 is equal to 3 ohms. This is the way how to convert its equivalent star network when they given delta network for us. Next, convert the star network in figure A to delta network. So this is the given problem. They given one star and one delta. We have to convert the star network into delta network. But here the values of star they given, that is here 1.6 ohms between 1 to neutral, 2 to neutral 5 ohms, and 3 to neutral, again 2.5 ohms. Now I want to convert what is the resistance which was offered between terminal 1 to 2, terminal 1 to 2 resistor. So now this is terminal 1, terminal 1 to 2 resistor, that is R12, which is equal to this resistor, that is R12. So R12, so what is the value of R12 here? The value of R12 here, it is the product of 1.67 into 5 divided by 2.5. So now the value of R12 here, which is equal to 1.67 into 5 plus 5 into 2.5 plus 2.5 into 1.67 divided by 2.5. Then if it is divided by 2.5, here we got 10 ohms. Then what is the value of R23? The value of R23, that is 223 in star again. So 5 into 2.5 plus 2.5 into 1.67, 1.67 plus 1.67 into 5 divided by 1.67. If it is divided by 1.67, then the simplified answer is equal to 15 ohms. Then what is the value of R31? The value of R31 is nothing but the resistance which was offered between the terminal 3 to 1. So again 3 to 1, what is the value means, that is 2.5 into 1.67 plus 1.67 into 5, 5 plus 5 into 2.5. So its value is equal to R31. So divided by 5. So check that here, divided by 5, numerator value this one, and divided by 5, and the simplified answer is 0.833. 2.5 plus 1.61 plus 0.8, that is equal to 5 ohms. So this is the way how to convert that the given star network into delta network. Let us go through that one more problem. Look at the problem here, problem number 3, that is determine the total current I in the given circuit. So I want to find out this current I. If I want to find out the current I here, I want to reduce this network into a single resistance value. That time the current I is equal V by R equivalent value. V means here they given 15 volts and R equivalent value I don't know. So I want to find out the value of R equivalent value as to find out the current I at here. As to find out the current I at here, I want to find out the R equivalent value. So let us, the current I is the total current which is driven by this 15 volts voltage source. This current I is going to divide it into two currents at here. One current is flowing through this 10 ohms, name it as I1. Another current is flowing through this 20 ohms, name it as I2. Again it will come to here. After that, one current will divide like this, one current will flow like this. Then again this current has to divide, go back. So there is a difficulty at here with this combination. So I want to reduce this delta network into star network because it is showing the difficulty to analyze the network at here. So I am going to take this delta network as a reference and I am going to convert this delta into star with the suitable formula. So this is the delta network and suitable star I want to calculate. If I want to calculate the suitable star means here, what is that R1 value, what is that R3 value, what is that R2 value. That means I want to superimpose this star into this delta. How? As like this. If I am going to take one delta as a reference, whose equivalent star I need. That means I want to make that resistance as one like this and one like this and one like this. I want to calculate its resistance, here resistance and here resistance. So I want this resistance. This resistance is nothing but that is product of 25 into 10 divided by 25 plus 10 plus 15. That is the solution, and here the value is equal to 5 ohms. Similarly, the remaining resistance value, one value got 3 ohms and another value got 7.5 ohms. Now these suitable star values I am connecting to that previous problem what they given here. Here I am going to replace these three elements with star network as like this. So here the value, here value, and here value I am substituting, and I am getting that the answers as like this. Here the resistance value got 5 ohms, here the resistance value got 7.5, and here the value got 3 ohms. Now if you analyze this circuit very closely, here, one current, that is I, is going to divide two currents, namely called as I1 here, and another one is called as I2 here. I1 is the current which is commonly flowing this 10 ohms and 7.5 ohms. I2 is the current which is commonly flowing this 20 ohms and this 5 ohms, because those are connected in series. Now that 20 and plus 5, it is 25. Here 20 plus 5, it becomes 25 ohms, and here 10 plus 7.5, it becomes 17.5. Again these two are connected in parallel. If you do that parallel network reduction technique, 25 into 17.5 divided by 25 plus 17.5, it becomes 10.29. After this 10.29, and again it is connected in series with 3 and 2.5, because all are connected in series. Therefore the overall current value can become as 0.95 amperes. This is the way how to reduce that complexity whenever it is difficult to analyze the currents, whether it is the relation between one resistor by another resistor, whether it is series and parallel. If it is any difficult, then the difficult delta is going to convert it into star. In this problem the difficulty is delta network, and I am converted the delta into star. In some other problems we can also, sometimes it is required to convert star into delta. So we have to approach that suitable technique, and we have to convert it as to find out the ultimate solution. So in this problem the overall current I is equal 0.95 amperes. Thank you.